Hi, today we're going to learn about scientific notation. Our goals are to write numbers in scientific notation and then convert between standard and scientific notation. In science, we often work with very large numbers, like Avogadro's number, or very small numbers, like Planck's constant. Obviously, working with either one of these numbers, there are so many zeros that working with them is a little bit unmanageable. Since our numbering system is base 10, we can use powers of 10 to rewrite very large numbers or very small numbers to make them easier to work with. Let's consider the two numbers 90,000 and 0.0009. First, let's look at 90,000. Another way that we could write 90,000 is 9 times 10,000, and then the 10,000 could be written as 10 to the fourth. So we could have 9 times 10 to the fourth power. Thus, another way to write 90,000 is 9 times 10 to the fourth power. 0.0009 is 9 10,000ths. So we could write that as 9 times 1 over 10,000. And then the 10,000 in the denominator we could write as 10 to the fourth power. Using our negative exponent rule, we could write 1 over 10 to the fourth power as 10 to the negative 4. Therefore, 0.0009 could be written as 9 times 10 to the negative fourth power. Here we have taken a standard number and we have written it in scientific notation. A number is expressed in scientific notation when it is in the form of a times 10 to the nth power, where a, our coefficient, we call that our coefficient, is between 1 and up to, not including 10, and n is an integer. Now we wouldn't want to go through all of this work every time we wanted to convert a number from standard notation into scientific notation, so we do have a little bit of a shortcut. Let's look at 90,000 again. So let's look at 90,000 again. We assume our decimal to be here. We want that a value to be between 1 and 10. So we could move our decimal place over 1, 2, 3, 4 places, and then we would just have 9. And when we move our decimal place to the left, that's going to increase the exponent, and it will increase the exponent the number of places we moved our decimal, so 4 places. Now for our number 0.0009, here we would have to move our decimal to the right 4 places, and moving the decimal to the right will decrease our exponent. So decreasing 4 units, or writing that as a negative 4. So again, if we were to have these two values, 90,000 and 0.0009, and we were asked to convert them from standard to scientific notation, for the 90,000, I would have my decimal place here. I'm going to move 1, 2, 3, 4 places to the left, so I'll have 9, and then every place I move to the left, I'm going to increase my exponent by 1. I move 4 places, so I'll write that as 10 to the fourth power. And for the 0.0009, I'm moving my decimal place 1, 2, 3, 4 places to the right. And every time I move 1 space to the right, that is decreasing my exponent by 1. I moved 4 places to the right, so we'll have 9 times 10 to the negative 4. So let's look at our first example. We have 300 million, and we want to convert that from standard to scientific notation. My decimal is here. I want to move my decimal to the left until I have a number between 1 and 10, and we can go 3, 6, 7, 8, put our decimal here. So we'll have 3 times 10, and that will be to the positive 8. Because we are moving to the left, we are increasing our exponent. For example 2, I have 0.0084, so I'm going to move my decimal 1, 2, 3 places to the right, and I'll have 8.4 times 10. I'm moving it to the right, so that will be 8.4 times 10 to the negative 3. And then for example 3, I have 670,000, and so we'll have our decimal place here. We'll move over 3, 4, 5 places, so our new decimal will be here, and that will be 6.7 times 10 to the 5th power. If you can keep in mind that if you have a positive exponent, that is a big number, and that if you have a negative exponent, it's going to be a small number. That will help you out as well. Okay, so for example 4, we have 0.0000507. So I want to move my decimal 1, 2, 3, 4, 5 places to the right. So that means I'm going to decrease my exponent. So I'm going to have 5.07 times 10 to the negative 5th. There again, I have that negative exponent, and that means I have a small number, which is what we have. Go ahead and pause the video and convert the following numbers from standard notation to scientific notation. So go ahead and check your work and see how you did. I hope you did really well on that. Now we will convert numbers written in scientific notation into standard notation. So let's look at 1.23 times 10 to the 6th power. 10 to the 6th power is equal to a million, so this would be the same thing as saying 1.23 times a million, which would be 1,230,000. If we had 1.23 times 10 to the negative 6, that would be the same as 1.23 times 10 to the 1 millionth, which would be equal to 0.0000123. Of course, we don't want to go through all this work. We want some kind of shortcut that we can convert these really quickly. Remember, when we have a positive exponent, that means we have a large number. So we're going to look at our coefficient, 1.23, and we're going to move our decimal right the number of places equal to the exponent. So our new decimal point will be here, and we'll have to put zeros in as placeholders, and then we could put our commas in there. Therefore, 1.23 times 10 to the 6th power would be equal to 1,230,000. So recall that if we have a negative exponent, that means we're going to have a small number. Here we will want to move the decimal to the left, the number of places equal to the absolute value of the exponent. So we'll move that decimal 6 places to the left, and again we'll have to put in some zeros as placeholders and a 0 out in front of our decimal as well. So 1.23 times 10 to the negative 6 would be equal to 0.000000123. Just keep in mind, if your exponent is positive, we have a large number, so we'll move the decimal to the right, the number of places equal to the exponent. And if your exponent is negative, then you're going to have a small number. You'll move your decimal to the left, the number of places equal to the absolute value of the exponent. So in this example, we have 7.194 times 10 to the 5th power. We have a positive exponent, so we're going to move our decimal place to the right 5 places. So we'll move our decimal place 5 places to the right, and we'll need to add in 2 zeros as placeholders. So we will end up with 719,400. Here we have 2.034 times 10 to the negative 3. We have a negative exponent, so we will move our decimal to the left 3 places. So start at our decimal, move to the left 1, 2, 3 places, and then again add a couple of zeros as placeholders. So we will have 0.002034. For example 7, we have 9.2 times 10 to the 8th. So moving our decimal 8 places to the right. Then we'll have to add in a bunch of zeros as placeholders. And then we can put our commas in here as well. That will help us kind of see what kind of number this is. So here we have 920 million. And example 8, we have 5.002 times 10 to the negative 2. So we'll move our decimal to the left 2 places. So here we'll have 1, 2, put our decimal here, which will give us 0.05002. So go ahead and pause the video and convert the following scientific notation into standard notation. So how did you do on that? I hope you did very, very well. Now here is a couple of challenging problems. Go ahead and write Avogadro's number and Planck's constant in scientific notation. So how did you do on that? Sometimes the hard thing on that is just counting up all the zeros without going cross-eyed. So hopefully this will help you with your scientific notation, and good luck.